Alright, Assalamualaikum and a very good day to everyone. So today let's continue our lecture, which is in chapter 2, which is a Fourier series part 2. Okay, so before that, okay, let's see the outline of our class for today. Alright, so for today we will continue with the trigonometric versus complex Fourier series, where this has been covered in our previous lecture. Okay, and now we're going to see into Parseval's theorems. Yeah. Okay, so let's look on the first topic, which is the trigonometric Fourier series. Okay, so Fs here denote for Fourier series. Yeah, I just wrote it as a short form, right, as Fs. So I believe you have seen this kind of this equation during your first year course lecture, yeah, either in your mathematicals or in other course lecture during your first year. So I believe you have already seen this kind of equations. Yeah, so from this equation, okay, you can come up with this signal. All right, and from this signal, actually, you can identify the coefficient of an, right, and also bn, yeah, the coefficient of an or a naught, yeah, and also bn or b naught, yeah, based on the sequence of the harmonics, yeah, based on the sequence of the harmonics. So now let's go further. Okay, so in this slide, yeah, you need to identify the properties of the signal. So there are two properties, yeah. If either that particular signal is even symmetry or odd symmetry, or it can also have a skew rotational symmetry. Okay, so how to identify these properties is based on the value of some of the value might be zero. For example, for even symmetry, your bn, yeah, your coefficient of cosine will be zero. Bn gonna be equals to 0. However, for the odd symmetry, your an, yeah, will equal to 0. Yeah, your sine like has sine like odd symmetry along the time axis above t equals to 0. Okay, so if the value of an, the coefficient of sine and cosine, is equals to 0, both of them is equals to 0, so that particular signal is known as to be as even values of n, and you're gonna have a skew or rotational symmetry. All right, so I think you just need to go through, you just need to read these properties, and then you can straight away identify the properties of that particular signal, yeah, by knowing the value of the coefficient, yeah, the bn an value. All right. And then next, proceed to the next. So for example, yeah, in this case, yeah, our Fourier series symmetrical properties, yeah, example. So you're given this particular from this particular equation, yeah, from this general equation. For example, if signal Vt is an even symmetry, for example, in the period of t, the equation for Fourier coefficient can be simplified, yeah, if it is denoted as even symmetry. Okay, if it is denoted as even symmetry, okay, your Fourier coefficient can be simplified that straight away your Bn equals to 0. Okay, because sometimes they're gonna give to you either the equation or the signal itself, so you have to identify. All right, so if your Bn is equals to 0, okay, so it is even symmetry. Okay, so if it is given to you this equation, so you can straight away look from this value, right? The value of Pn. So if it is not given, for example, the equation is not given, but then it's given to you the graph. So if you can determine, okay, you can identify from this graph, oh, this is a symmetry graph. So therefore, it can be, so therefore straight away you know that Pn is equals to 0. Okay, and then how for you to determine your An is based on this equation. Yeah, so if the signal is odd symmetry, okay, if the signal is odd symmetry, so it is opposite way, okay, it's opposite way round, okay, your An now are going to be equals to 0, and your Pn will be as this equation. All right. Okay, now let's look into this example. Okay, so in this question they ask, find the trigonometric Fourier series for VT until the fifth harmonics. So they ask you to come out the Fourier series for this type of signal, and they given to you very specific how many harmonics that you want. Alright, so here are the solutions. So these are quite conventional method for you to solve this particular type of questions. So first of all, you look at the figure. Okay, so now based on the figure, we know that it is an odd symmetry. Okay, it is an odd symmetry waveform. So therefore, your An is equals to 0, and your Pn you're gonna have a value based on these integrations here. Okay, so from here, what you have to determine is you don't have to anymore determine the An because An is equals to 0. So left behind, you need to determine your Bn. Alright, so for you to determine your Bn, you need to identify your T, which is your period. So based on this is the T here. This is the period. So the period is 2 milliseconds. Okay, it is a 2 milliseconds. So once you know your period, how much period it is, the value of the period, yeah, the period, one full cycle. So we know that F is equals to 1 over T, and then we know, because we need to determine the omega, right? But then we know the omega is equals to 2 pi F naught. Alright, so it can be converted into 2 pi over T naught, right? Because your F naught is equals to 1 over T. Alright, so once you determine your T, the value of your period, so therefore you can straight away get the value of your omega. Alright, so once you got the value of your omega, you can solve this particular integrations. Okay, and then you will get your final solution, that your Bn, this is your general equations for your Bn. Alright, your general equation for your Bn, which is the coefficient of sine. Yeah, so once you got this, since the question asks you fifth harmonics, right? Fifth harmonics. So you just have to replace inside here when n equals to, from n equals to 1, 2, 3, 4, and 5. Alright, for you to get until fifth harmonic. Alright. Okay, so this is your final. If you solve this particular equation, is question, you will get this is your final answer that you're supposed to get. Yeah. Okay, now let's go further. All right. So we have learned before about Euler's, yeah, Euler's theorem, where we use Euler's theorem to convert from trigonometric function into exponential, complex exponential form, right? So in this part 2, we are still using this Euler's, alright? So from the Euler's equations, Euler's theorem, we know that the cos is equals to cos, and everything inside the brackets is going to be exponential j and omega, which is everything inside the brackets, yeah? everything inside the brackets, plus exponential negative, everything inside the brackets over 2. And for sine, okay, this easy to make it as bracket, yeah. For sine is equals to same as cos, but only the difference is instead for positive for cos, it's gonna be minus here, and then the down part are gonna be 2g. All right, so that's the difference between cos and sine. All right, so from this Euler's theorem, okay, you will then be introduced into a Fourier coefficient table. Okay, you will then gonna be introduced into Fourier coefficient table that I'm gonna show to you the next slide. All right, and then if you want to use that Fourier coefficient table, okay, you need to identify this first. Yeah, you need to identify the component of C naught, the component of Cn, and the component of C minus n. Right, so how to determine these components is based from this Euler's theorem. Yeah, so this is the original Fourier series here, which is the original Fourier series form is in the trigonometric form. Okay, so from this trigonometric form, you can always convert it into a complex Fourier series form, okay, complex exponential Fourier series form by applying the Euler's theorem. Right? So this is from our previous lecture, right? So from there, once you got the complex exponential of Fourier series, then you can identify straight away the value of C naught, the value of Cn, and the component of C minus n, right? Okay, now, okay, so from that, right, from there, we can simplify, yeah, we can simplify the complex exponential form into this particular of equation, right? From this particular of equation, and from this equation, we can again, yeah, from this equation, we can again simplify into this component, okay, into this equation. All right, so where this equation is very, very important, okay, where you're gonna use this throughout this chapter, okay. All right, so before we go to the Fourier coefficient table, okay, I would like to show to you the example of questions first, okay, and then I'm gonna show to you how to apply into the Fourier coefficient table. So we're gonna have equation here, example of questions here. For example, write the complex. The question asks here, write the complex of Fourier series of this signal st up into third harmonic. So they want you to, the value of n now is equals to 3 into third harmonic. So if you get this kind of question, you need to use this kind of general equation. Yeah, general equation. And what are the steps? So the first step that you need to know is you need to refer to the Fourier coefficient table. So the Fourier coefficient table is this table. So you don't have to worry. This table usually will gonna be provided during your final exam. Okay, during your final exam, don't worry. This table gonna be provided to you. Okay, so there are 7 types altogether. Okay, Fourier coefficient table. The first type is the square wave. We're gonna have square wave. So you need to know the component of x naught and t naught. Okay, so x naught is the value of the amplitude, the signal. Okay, the amplitude of this signal. Okay, and t naught are gonna be the periodic of that particular signal. Okay, and then what also that you need to know from this Fourier coefficient table is the value of the first component is C naught, and then they're going to have another component which is Cn component, and also you need to look at the comments here. Okay, for example, the first type, of wave, yeah, square wave. For square wave, the component, okay, so this is how the waveform gonna look like, okay. So the first C naught, okay, the first component, which is C naught, is always 0. So when C naught is 0, you can straight away, you look into the table, you can straight away identify or recognize that, oh, that particular signal is going to be in a square wave shape. All right, so you know, you already gonna have you can already imagine in your mind that your signal shape are gonna be in a square wave shape. Okay, and next you look into the next component, which is the Cn component. So for square wave, the Cn component are gonna be minus j 2x naught over pi n. Okay, minus j 2x naught over pi n. So what is x naught? X naught is the amplitude. Okay, x naught is the amplitude. So that particular amplitude over multiply with 2 over pi n. So you can identify your Cn. And then what is the comments? So you need to also pay attention at the comments part. So for square wave signal, your Cn is equals to 0 when your n is even. So your n that you need to consider will gonna be the odd value. So it's gonna be 1, 3, 5, and so on. Alright. So when if you put if you're in the even number, yeah, for example 2, 4, 2, 4, 6, your Cn will equals to 0 for a square wave signal. Alright, so different types of signal, we're gonna have a different value of C naught, Cn, and comments. Yeah, for example, for sawtooth and triangular wave, the component of C naught is same, which is the amplitude is divided by 2. However, the only difference is at the comments here, and also the Cn, yeah, for the Cn. Okay, and also for the components, for the comments here. So please pay attention at the comments here. So altogether, we're gonna have 7 types of square wave signal. The first one are gonna be square, sawtooth, triangular wave, full wave rectified, half wave rectified, square wave, impulse train. Okay, so please get familiar with this table. Alright, so now let's go back to the previous slide. So the first step, if you have this kind of question, refer to the Fourier coefficient table. Look which signal is this signal, okay, is this signal closest to. Okay, for example, in this particular signal that given to you, straight away we can say that it is closest to the triangular wave, right? It is of course, it is obviously not a sawtooth, yeah. Okay, then next, compare directly the given graph here, and then determine the x naught and t naught, the value of x naught and t naught. So think in this in this question, okay, so this is going to be the value of x naught, right? And then what the value of your t naught? So this is going to be your value, or the value of your t naught, right? Okay, and then calculate the value of Cn. Okay, once you already determine your x naught and t naught, right? So you can straight away determine your Cn value, all right, and also your C naught value, right? And then write the complete complex Fourier series for the whole signal to the required number of harmonics. Okay, now let's try to solve this particular questions. Yeah. Okay, so now this is the question again. Yeah, this is the question again, and they ask you to write the complex. Yeah, they ask you to write the complex Fourier series, and then the number of harmonics is n equals to 3. Yeah, the number of harmonics that is required is until 3. Okay, n is equals to 3. Okay, so now following this kind of step, okay, following these steps, Okay, so now let's identify which are the following signals is the closest to these questions, right? So it is closest or nearest with the triangular wave, right? It is closest to this triangular wave. So from this triangular wave, we know that the C naught component is x naught divided by 2, all right? So this wave, okay, now look back again to this wave. So where is your x naught? So this is your x naught, right? And this is your t naught, all right? So for you to determine your c naught, so it's gonna be and then please pay attention also, this is in a millisecond. Okay, so your c naught straight away we're gonna be 2 divided by 2, right? Your c naught we're gonna be 2 divided by 2, and then your t naught is 20 millisecond. Okay, 20 millisecond, and from here you can determine your omega, right? Because omega is 2 pi f, so it's equals to 2 pi over t, right? So you already determine your t is equals to 20 millisecond. So it's going to be 2 pi divided by 20 millisecond. So it's going to be 100 pi. Okay, so once you know that, now you can have your complex Fourier series. So the first component we're going to be C naught component. The next component we're going to be your Cn component. All right. So this is based from, so the first component are going to be C naught component, and the next component are going to be your Cn component, all right? Cn component, but then don't forget with your exponential here. Okay, so now your Cn component, we already identified that. Your Cn component is going to be minus 2x naught over pi n squared, right? So your Cn component are going to be minus 2x naught over pi n, and then both of them are going to be square, right? And then in front here, C naught. So your C naught is this component, right? So you just replace this particular value inside here, okay, inside here, and then you will get this equation, right? Okay, now this is not settled yet. So you need to replace the value of x naught, you need to replace the value of n, and then you need to replace the value of omega, all right? So to solve this, okay, so all right, so now from this equation, now let's include the value of x naught, since the value of your x naught just now is 2, and then your value of t naught, sorry, t naught is also 2, t naught is also 2, right? 20 millisecond, and then your value of omega just now is 100 pi. Okay, so you just has to replace inside this general equation. So x naught is equals to 2, and then minus 2, x naught again 2, and then pi, and then n, you just leave it as n. Okay, and then omega is 100 pi. Okay, so now let's replace the value of n. Okay, replace value of n. Okay, replace the value of n, and then if we look at the comments, there is a comments here. Okay, the comments said that Cn is equals to 0 if your n is even. So therefore, since that they asked to you, you have to consider n is from 1 until 3, right? So the even number is 2, right? The even number is 2, so you don't have to consider this 2. Okay, you don't have to consider this 2, right? So now the only number that you have to consider is 1. Okay, when n is equals to 1, n is equals to minus 1. So you need to consider both, yeah, positive and negative part. And then n is equals to 3, and n is equals to minus 3. Okay, all right, so don't consider the number 2, because even number, the value of Cn is equals to 0. So don't waste your time. You don't have to consider this even number. Alright. So just replace the value of n inside here with the value of each particular n. Okay, that you need to consider with. Alright. So when when n is equals to 1, so this is the value of your C1. Okay, when n is equals to -1, so don't forget the to determine the negative value as well. Yeah, so your c minus 1 is equal to as such. For c is equals to 3, so the value going to be as such. C is equals to -3, the value is as such. All right, so now let's put inside this equation. Okay, let's expand. Okay, so now let's expand this equation. All right, so 2 divided by 2 we're going to be 1. So this is your C naught value, right? Okay, so this is your C naught value. Okay, so this is your C naught value. Okay, now next, your C1 value. Okay, C1 value. So your C1, it is negative. So there you are, it is negative here. So 4 over pi 2, 4 over pi squared. Okay, 4 over pi squared. And then don't forget the exponential behind here. Okay, so the exponential j, so your n is positive 1 now. So n is equals to 1. So your another value is 100 pi t. So 100 pi t now it is. Okay, so now next let's consider when c is equals to -1 now. So when c is equals to -1, okay, it is negative 4 over pi squared. Negative 4 over pi squared. Okay, exponential, don't forget the exponential part. J, so your n now is negative 1, so they're going to put a negative here. Okay, and then 100 pi t. Okay, and then c is 3. Okay, when c is 3, so the value is still negative, negative 4 over 9 pi squared. 4 over 9 pi squared. So your exponential now we're going to be 3. So it's going to be 3 multiply with 100. So it's going to be 300 pi t. Okay, and then the next component is c is equals to -3. So the value is -4 over 9 pi squared. And then the exponential, since that it is -3, so -3 multiply with 100, so it will become -300. Okay, so now let's simplify this equation. Okay, so now let's simplify this equation. If we can see the second term, this term, yeah, and this term, it can be compiled together. So we just bring negative 4 pi squared in front, and then bracket e exponential j 100 pi t plus, yeah, plus minus we're going to be minus, right? So plus e minus j 100 pi t. Okay, and then this component somehow can be simplified with this component as well, right? So minus 4 over 9 pi squared, you bring it in front, and then bracket ej 300 pi t. So since that it should be minus, so minus plus is going to be minus, right? So they're going to be plus inside here, exponential minus j 300 pi t. Okay, now, so this is not settled yet. Okay, we know that we can change this negative term into positive, right? We can change this negative term, both of this negative term, into positive by making a phase shift, right? By making a phase shift. Okay, we can change this into positive, make it as positive by phase shift. Okay, so how we want to make how by phase shifting can make it into positive? By plus pi. Okay, plus pi. Alright, so we plus pi inside here. Okay, so it's gonna be 100 exponential j 100 pi t plus pi. So straight away in front here we're gonna be positive, and this also plus pi. So straight away in front here we're gonna be positive. Yeah, both of it plus pi, so it's gonna be positive. So same goes to here. Okay, both of this component, okay, both of this component, if we plus pi, the in front here we're gonna be positive, right? Okay, so now these are the general, the normal complex exponential Fourier series, right, that we have learned in part 1, right? So now from here we can draw the graph, which is the amplitude graph. Okay, the amplitude graph and the phase spectrum, the amplitude spectrum and the phase spectrum. Okay, so now this is the C naught component. Okay, so and then this is our omega 1. Okay, omega 1, sorry, it's better to write omega 1, right? And then this is going to be our omega 2. So this is omega 3, and this is going to be omega 4. Okay, so omega C naught we're going to be 1, so there is no phase shift and omega, so it's going to be on 0. Okay, on 0 or on 0 lah. Okay, omega equals to 0, so it's going to be, the amplitude is 1. Alright, and then our first component of omega 1 we're going to be 100 pi t. So the first component we're going to be 100 pi t. So what is the amplitude? The amplitude is 4 over pi squared. 4 over pi squared, right? So the next component of omega we're going to be minus 100 pi t. So minus 100 okay, minus 100 pi. Sorry, I forgot to write here pi. No? Supposed to write here pi, and then pi. Alright, minus 100 pi t. So what are the amplitude? The amplitude is same, 4 over pi squared, right? And then the third component of omega we're going to be on 300 pi t. So 300 pi t, okay, 300 pi t. So what are the value of the t, the amplitude? So it's going to be 4 over 9 pi squared. So 4 over 9 pi squared it is. So the omega, the fourth component of omega we're going to be minus 300 pi t, minus 300 pi t. So the amplitude we're going to be 4 over 9 pi squared as well. Alright, so this is how the amplitude spectrum is going to look like. Okay, so based from this equation you should know the hint that it should be in a double-sided, okay, because we know Fourier exponential form will give us double-sided graph, right? Double-sided spectrum, so it's going to be double-sided. So you're going to have on the first quadrant, also on the next quadrant as well. Okay, so now let's go to the phase. So phase, so the x-axis are going to be same here, 100 pi t, so pi t, 300 pi t, minus 100 pi t, and minus 300 pi t. It must be same, yeah, with the amplitude and the phase, yeah, the x-axis, yeah. And then the difference are going to be the y-axis, right? So on the first component of omega, the value of phase, yeah, the value of phase is positive pi, so it's going to be pi here. It's positive here, positive direction. The second component, positive, negative. Don't forget the negative in front here. Yeah, negative, positive, so it's going to be negative component, so it's going to be negative pi here. So this is negative pi. Alright, and then the third component of omega, we're going to be positive pi, so this is positive pi. And then the fourth component, positive, negative, it's going to be negative, so it's going to be negative pi. Alright, so this is the final answer. that you should get. Okay, all right. So now let's look into the next example. Okay, let's look into the next example. So it's given to you this type of graph, right? Okay, and then they ask for you to write the complex Fourier series form. Okay, complex Fourier series form. So when they say complex Fourier series, so you should know there must be exponential, positive, negative, or something those like that, right? And of course, when they say complex, you should sketch a double-sided spectrum. Okay, it is not it is not common for a complex exponential to draw or to sketch a single-sided spectrum, single-side spectrum or one-side spectrum. All right. So complex always goes to double-sided. Trigonometric form will always go to one-sided spectrum. All right. And then what they ask you, you need to draw that particular signal until third harmonic. So your n is equals to 3. So you need to consider 1, -1, 2, -2, 3, -3. Right? So these are the value that you need to consider. Okay, so now let's look. Let's try. So the first solution is you need to compare with the Fourier coefficient table. Okay, so by looking at this graph, we can see here that it is similar or it is closest to sawtooth. So once you already identified that, so you need to know the value of x naught and t naught. So for x naught, this is going to be your x naught value, and this will going to be your t naught value, right? And then you need to pay attention as well to the component of c naught component, okay, and then your cn component, and then there's no remarks here, so good. Okay, there's no remarks here. Okay, so now let's try to solve this particular question. So first of all, you need to memorize this general equation. Okay, general complex Fourier series equations. Yeah, so the first one should be c naught plus sigma. Okay, and then your n is going to be from minus exponential minus infinity into infinity, so it can be any number, okay, as large as it is not 0. Okay, it can be any number as long as it is not 0, because your 0 is going to be in c naught, right? So that's going to be your cn, and then don't forget the exponential part behind here. Okay, so from the table sawtooth signal, we know the value of x naught is equals to 6, the t naught is equals to 1 second, so therefore your omega will gonna be 2 pi. Okay, your omega is gonna be 2 pi. So from here we can replace with this particular, all this value we can replace inside this general exponential equation. So we will get 6/2. Okay, so your c naught is going to be based on this, right? You're going to be based on this, right? So once you identify that value, so you can just squeeze inside this equation, okay, and then you will come up with this equation, right? So from this equation, okay, what you have to do is you need to replace inside here. You need to replace the component of Cn into the components, into the numbers of harmonic that they required. So 1, -1, 2, -2, 3, and -3. Okay, so you just squeeze inside here. All right, so you will get 3/pi exponential, okay, j pi over 2. Okay, j pi over 2 pi over 2, because 1, right? 1, okay. Pi over 2. Okay. Exponential. Oh, okay. 6 to pi. Sorry. Okay. 6 to pi 1. Okay. 6 to pi 1. 6 to pi 1 from this Okay, it's gonna be 3 over pi, and then 3 over pi, since that there is a j behind here, okay, so therefore you can change this into here. All right, okay, all right, we can change into here. And then so same goes into the rest. Okay, same goes into -1, and then same goes to negative 2, -2, 3, and -3. Okay, all right, so why we need to, some of you might ask, yeah, why we need to convert from this equation to be into this term, because we don't want to deal with this j in front like this. Okay, it's very complicated to deal with this j in front like this, so therefore please convert this into this equation. Okay, all right, so now you have already your Cn component for each number of harmonics. So now let's expand this equation with the value of harmonics that is required. Okay, so this should be your C naught. This should be your C naught. Okay, your C naught is 3. Okay, and then this should be your C1. Okay, this should be your C1, 3 pi exponential j pi over 2. And then this will gonna be your, when your n is equals to 1. Okay, your n is equals to 1. So don't forget behind here. Okay, so this is coming from behind here. So e exponential j n is equals to 1. So 2 pi t. Alright, and then this is on the second component, the -1, 1. Alright, so this is C -1. Okay, and then this is when your n is equals to -1. And same goes this for the next. This is C 2, and then this is when your n is equals to 2, and then this is your C -2. So this is your n is equals to -2, and then this is your C3, and this is your n is equals to 3, and this is your C -3, and this is your n -3. Okay, so this is not finished yet. Of course, we need to proceed. Okay, we need to simplify this equation. So the second term and the third term we can simplify into this term. Okay, and then the next term, which is the fourth and fifth, we can simplify together. Okay, because the amplitude is the same, so simplify it together. Okay, and then next, the sixth and seventh, right? This one can be simplified together. Okay, so the tips to simplify this is by looking at the value of the component, the amplitude. Yeah. Okay, now after that, once you simplify that, all right, once you simplify that, you can see inside here your exponential going to be j pi over 2 multiply with exponential j2 pi t, right? So I think you have learned this in your additional mathematics during your high school. When multiply of exponential is going to be positive here, right? So j pi over 2 plus pi over 2, okay, j pi over 2 plus j2 pi t. All right, okay, so you just factorize the j in front. Okay, you're gonna have the inside components as such, and then from here it's gonna be minus j pi over 2 minus minus j2 pi t, and then you can factorize the j in front, so it's going to be minus pi over 2 minus 2 pi t. Okay, and then this minus also we can bring it in front, so it can be minus j pi over 2 plus 2 pi t. Okay, and then you can see inside here in this one term, yeah, in this bracket, you can see the exponential at the bracket is always the same. This is our objective. Yeah, this is our objective. Why we bring the minus in front? Okay, because we want to make sure that the exponential, the bracket at the exponential part, will become the same. Okay, will become the same value. Or it will gonna look like similar. Okay, so same goes to here, same goes to here, and same goes to this following. All right, and then from here, okay, from here, then you can see, check again the equation, either there is a negative, negative or not. So now in this equation there's no negative, so there's no phase shifting required in this equation, so therefore you can straight away plot the graph. Yeah, so since that it is a complex exponential Fourier series form, so they're going to be a double-sided graph, a double-sided spectrum. Yeah, so this is going to be so C naught. Okay, C naught. Okay, when your omega is 0. Yeah, so and then the first omega term going to be 2 pi, so the amplitude we're going to be 3 over 4, and then the second term is negative 2 pi, the amplitude is 3 over pi. All right, and same goes to the rest, and then so this is the amplitude spectrum, and this is going to be your phase spectrum. Okay, so your phase spectrum, you just look at the behind part, okay, but then don't forget for this part there's negative in front here, so you're gonna face downward like this. Okay, and also please don't forget to rename your axis. Yeah, okay, so it's quite easy, right? Okay, now let's do another way around. There's also a possibility that they will ask you to sketch the signal, okay, where they give to you the spectrum. Okay, so from this spectrum you need to sketch the signal. So how? Okay, so it is just another way around from example 2 that we have done just now. All right, so the question asks, write the mathematical expression in trigonometric form. Okay, so you need to write the expression in trigonometric form, and then they ask you to sketch the single-sided spectrum. Okay, sketch the single-sided spectrum. Okay, so now let's try to solve this part of questions. So the solution, the first thing that you need to do is write the mathematical expression. Okay, write the mathematical expression from this spectrum that has been given to you. Okay, so you know that this is amplitude or magnitude spectrum. Okay, this is amplitude spectrum, and this is a phase spectrum. So try to come out the mathematical expression from this given spectrum to you. Okay, so how? So you can see here, so these are going to be the value of omega, right? And these are going to be the value of amplitude, okay, something in front here. And these are going to be the value of phase, right? So the first thing, C naught. So your C naught is start from 0, okay? So straight away the value is 3, right? So straight away the value is 3. Okay, so now let's look on the next component. So the next component, the omega is 2 pi. Okay, so the omega is 2 pi. So straight away this is omega, because you know, you already know, right? The general representation should be C naught plus amplitude, sorry, okay, amplitude exponential j omega t plus this. Okay, so I think it's better for me to write with, I'm gonna erase this part with it will be okay, right. Alright, so omega 1, omega 1 theta 1. Okay, omega 1 theta 1, and then plus e minus j omega negative 1 t plus theta negative 1. Okay, and then you can continue. Okay, and you just have to change need to change the value of amplitude for the following. You just need to change the value of amplitude, the value of this, the value of that. Okay, so therefore the next term we're going to be amplitude for the second term. Okay, so this and this is always, so let's use the first color, the same color, so that you will not get confused of that, right? Okay, this and this is always this in one, I mean in one term. Okay, and then okay, this and this are gonna be always this the next term, and then the next term gonna be this and this. All right. Okay. So the next we're gonna be amplitude. Okay, and then e j omega 2 t plus theta 2, and then plus exponential minus j omega minus 2t plus theta minus 2. Okay, and so on. All right, so you can come out with this mathematical expression easily. Okay, you can come out with the mathematical. The first one is 2 pi. Okay, because the value is 2 pi here. Erase this one. Okay, so it can be clearly seen. Okay, so this is 2 pi here. Okay, so 2 pi t plus theta, right? So what is the value of theta? The value of theta is pi over 2. So pi over 2. And then this is always related to this. So minus exponential minus j 2 pi t. Okay, still 2 pi t. Okay, minus 2 pi t, minus in front here, 2 pi t. And then minus pi over 2, but then you bring the you already bring the minus in front, so it's going to be positive pi over 2, and so on. Okay, so you can come out this equation by looking at this both graph. Okay, now once you have come up with that particular equation, the next what you have to do is you group the component. Okay, group the component in exponential for cosine function. I always recommend you to go for the cosine function instead of sine function, because sine function is always have divide by 2j, right? If you still remember, for cos okay, for cos omega naught, okay, omega naught t plus theta naught is always exponential j omega naught t plus theta naught plus e minus j omega naught t plus theta naught, and then divided by 2. So this is for cos, right? But for sine, it will be plus theta naught. Okay, this is theta naught, yeah? Is equals to exponential j omega naught t plus theta naught minus exponential minus j omega naught t, whatever inside the bracket, yeah, divide by 2j. So you're gonna have 2j down here for sine. So I always not recommended you to go to this sine. So please go to this cos, yeah. So go to the cosine function. Okay, so we know that the cosine function we need to divide with 2. So how to do that? We need to multiply the in front with 2. Okay, in order for you to divide inside this particular bracket with 2, right? So this is mathematics, yeah. 2 and 2, okay, and then for all everything, yeah, 2 and 2, and then after that, once you have done this, so you can see inside here, this is cos, right? So you can change here, cos whatever inside the bracket, cos whatever inside this bracket, cos whatever inside this bracket, okay? And from there, you can straight away, okay, from what we have learned in part 1, okay, you can straight away plot the amplitude spectrum and phase spectrum, okay? And don't forget the what, C and R. Don't forget the labeling the axis, yeah. So this is theta, so this is omega, okay? So omega radian per second, okay? So simple, right? So I hope you can understand this, right? Please look back this method, okay? Both method, both way you should know, yeah? Either they given to you the spectrum and you need to find you need to sketch this signal, okay? Or they give to you this signal and you need to sketch the spectrum, okay? And there's also a possibility where they give to you this spectrum and you need to sketch, or you need to identify which type of Fourier coefficient wave it is. Alright, so please be prepared as well for that. Alright, so by that, thank you very much, and Assalamualaikum.